This video describes the procedure to develop orthographic views using SolidWorks. So we have a bearing as prepared in a previous video. We'll make use of the same part to generate orthographic views. To make an orthographic view, we open up the new file from the standard toolbar. In the dialog box, select the extension as drawing file type, say OK. The paper size or the standard sheet size for this particular exercise, we'll pick it up as A3 landscape. Say OK. And there's a property manager for the model view with the bearing listed here. We'll come back to this a little later. We'll try to fill out the details that are here in the standard title block at the bottom of the sheet, and then include the necessary views in the drawing sheet over here. So to make changes to the title block, right click on the sheet, say edit sheet format. We can zoom into this area. We have got the first text here as the units. We have dimensions given in millimeters. So since we have used inches, we will have to replace it. Simply double click on the text to replace millimeters with inches. Then you may click outside to move out of the edit mode of that particular text. You have some other details like the name, signature. We will replace the signature with your ID number. So double click to make this as ID number. For the name, we'll have a note coming in from annotation toolbar. Select note, and in the property manager for the note, we'll assign a font style. So uncheck the box for document font and say font. Let's assign the font style as book antiquad. So this is the one that we will use with the unit as 3.175. We will change this based on the available space for the text. So you may write this anywhere on the drawing sheet and then later drag and drop it into the cell. I'll put my name here. Then we can make another click to add other details like the ID number. I'll leave it with some arbitrary characters, so you may fill out your actual ID number there. Then we have got the date. We'll put this as today's date, 1st of October. We have got the material to be specified, so I'll also write that over here. We'll try to later drag and put it into the place for the material, cast iron. So for now I'll stop here, and then let's fit these fields in their respective positions. We have got the name here. You can drag and drop it into the space for the name. If in case you find that the space is not sufficient to fit that, you may decrease the font size. Double click on it, and in the quick toolbar over here, this is 12. Let's make it 10. I have got the ID number, so hold this, put it over here. You have date, fits in there, so I don't need to change the font size. And for the date, we need to reduce the font size. Now for the material, I'll remove the existing reference here for the material and then replace it with cast iron. If you have calculated the weight using the mass properties, you may enter it in the cell below it, else you may simply remove the text that you see next to the weight. We have got the scale as 1:1. We'll use the same scale. We will sheet 1 of 1, so it's only one drawing sheet, so we'll have the number as 1 of 1. Paper size as A3. Drawing number here gets updated automatically when you assign a file name. So currently it is draw 1, so it's the same that appears here. Once we save this file, it would get updated. Title, we would replace this and add the title as bearing. The cell above here is for allocating the name of, or assigning the name of the organization for which you're making this drawing. So we'll put the university name over here. We have got some other details like revision number or do not scale drawing, deeper and break sharp edges. We'll carry this forward as it is, and for the finish we'll simply write here as we'll delete what's existing there and replace it with C machine symbols, and we'll put the machine symbols individually on the faces that are need to be machined. So I would go over a note again to include these other details and assign the same style. Try to be consistent with the font style. You may use one or two, but try not to have multiple font styles. This is the one which is mostly used on drawing sheets. So we have the same font style here, and then going in here to write the title as bearing. We can increase the size. We have got the organization name, so I'll drop this here, and then we'll give this as KFPM. To assign the general tolerance, we go over annotation, select note, and the linear general tolerance will give it as a plus and minus 0.02. So we have the symbols in the property manager, plus and minus. This is going to be 0.02 inches, and we have an angular general tolerance as plus and minus 1 degree. So we just replace this number with 1, add a symbol of degree from the property manager. Let's reduce the font size to 10 for both of these numbers. And then bring it down into the title block. This will go on all the dimensions which does not have a specific tolerance specified in the drawing sheet. So with this complete, okay, before we go to the drawings, there's another missing detail here, the projection method. We have a third angle projection mode, as the symbol for it is to be included in this particular title block. So let's create some space here to add that. I will delete this line here, hold the line endpoint and drag it a bit up to create space, and these lines we pull it to the left. Okay, in the cell created here, we'll try to add the symbol of third angle projection mode in the form of two circles for the front view, two concentric circles. So select sketch circle command and draw two concentric circles for the truncated cone, and we have a trapezoid to be sketched on the right side. So we will have the top, take a inference from the top end of the circle inner circle, go until the bottom of that circle in a vertical manner, and draw out an inclined line to reach the bottom of the bigger cylinder, bigger circle. Go up all the way to the top of this large diameter circle and close it from the side. Add center lines and center marks. So for the trapezoid here, we'll have it coming from the midpoint here. That's the vertical line for the center mark. Another one for the horizontal. Okay. You can also add the section number. So you may write here section and add the section number over here. So that would complete the title block details. We would move back into the edit sheet format. So you may simply move out by clicking on the icon on the top right corner over here, or right click on the sheet and say edit sheet. So this will move you out of the title block, and then you will be able to add the rest of the details. So let's try to add the orthographic view starting with the front. So this could be done by going over the drawing toolbar, select model view, and select the file that is open in the background, or browse it if it's not open, and click on next. When you click on next in the property manager, you have orientation. The file, the view that needs to be inserted here is described as isometric view. So change it to front view and drop the front view into the screen. Now you may project views from the front view. Simply drag the mouse and you may start dropping the other views like the top or the right side view or the isometric view and so on. So these are the various views that you can include, standard views that could be included in this manner. In case you happen to say OK and move out of that command and you wish to get more views projected from the existing one, you can still do so by going to drawing toolbar, select projected view, and select the view which is the parent view or the front view in this case. Select this and try to drag a view out of it. So it could be from any other view as well. Let's say you want to get something on the right side of the front, you can select the top view and then project a view from it. So this is the one way to do the orthographic views or add them in this drawing sheet. The second way, so let me delete these. Okay, the alternate method by which you can add this is by opening up the view palette in the task pane and then select the file that is open. If it's the bearing here which is already open in the background, else click on the three ellipse here to go to the path and open it from there. Select the file type or the file that's bearing, and it should show you the standard views that would come from the bearing. So it's loading it. Now we have got the standard view like front, top, back, and so on. So I'll select the front view, drag and drop it into the screen to generate the orthographic view for it. We have the projected top view and the right side view to be included here. So we'll try to simply move the cursor up such that it would give us the top view and the right side view. Say OK to move out of this command and remove the tangent edges that we have. So we have got two circular edges here coming from the ends of the fillet that you have, fillets and rounds that are existing on this part. So right click somewhere in the orange highlighted box around the view, select tangent edge and say tangent edge is removed. Do the same with the other views. We have got the top view, right click in it and then assign tangent edge is removed as a property there. We do the same in the right side view. turn on the hidden lines. To turn on the hidden lines, you may simply select the front view and change the display style to hidden lines visible. This would be applied to the other views. So the same parent style of the front view is applied in the derived views. Now we will replace the right side view with the sectional view, a section plane passing through the center of this part as a full section. So for this, you may select the section view under drawing toolbar. In the property manager, select the section. So this is the tab in which we get the full section. Cutting line as vertically oriented to describe the right plane as a section plane, and place uh, the pointer onto the origin or the center of the circle. And that's our first click. Say OK, and the view that would be generated from it could be dragged and placed on the right side. Now look out for the section line that has come up at this location. It has got direction arrows. So these are the viewing direction for the section plane. And if you feel that the arrows are pointing in the other direction, you may flip it. In the property manager, you have got flip direction to flip the way it is being looked at. So this is actually being seen from the left side. It is more appropriate to make it to the left side here, so a person standing on the right would look through the direction of these arrows, and the part over here would be removed. The section view that will be generated over here is shown on the right side. Accept this, and this right side view we can either delete or hide. So you may click somewhere inside the orange highlighted box there and say hide. Let's go for more options. It's over here, hide. We now add the center lines for all these cylindrical objects. Go to annotation toolbar, select center line, and then drop it over here between the two visible edges to get the center line for the bore and the cylinder that we have here. We have got another one here as a bolt hole, third one at the bottom. Do the same in the top view. Either you can select the ends between which you wish to have the center line, or the region between uh, region describing the cylindrical features. So these are the three center lines that we have on the top view. We add the dimensions from the annotation toolbar. We have model items as the command in it. In the property manager, select the source as entire model, and by default import items into all views is checked, so retain that. And also mark for drawing dimensions is checked. So these are default selections. You can keep it as it is and say OK, and you'll find all the dimensions getting dumped into the various views that we have here. These dimensions were used in making the 3D part file. These are being shown as a converted value in millimeters. So we switch to a inch system. Change the units from the bottom of the screen. You have got inch as the units. We find the numbers getting updated to the values as was provided in inches to make this 3D part. We need to rearrange these and put them in these orthographic views to have a drawing which is neat and as per the standards, following the dimension standards. So we'll try to move the depth dimension in the top view. We have got a fillet radii here, so let's pull it out, or rather we can replace this with a note. So simply right click and say hide, and then let's write a note here, all rounds and fillets to have a radius 0.12. We can increase the font size. This would be like 16, and we are done with it. We have The depth dimension 0.75, simply select this dimension, press the control on the keyboard, keeping the control key pressed, move it to the top view, and then you may hide the one that already exists in the front view, in the side view. So try not to have superfluous dimensions. It should be only indicated in one of the views, not at both the locations. So this is 0.75. We'll try to add the second one, which is 2.12. Select this, hold it by control key, keeping the whole control key pressed. Move the cursor to the top view to shift it from right side to the top view. Hide it from the right side view. We have got the other dimensions as the dimensions of the cylinder and the bore that comes inside there. So we'll try to assign the value like 5.5 at the outermost end, the smallest one to be specified first, such that there is no intersection between of a dimension line. So this is how we have got an intersection currently. Now the dimension line here is being cut by the extension line of 2.76. This is not standard practice, so try to keep the smaller dimension first, followed by a larger dimension. So we can create some space here by moving the front view to the left or shifting the right side to the left to the right end to create more space to add these dimensions. We have diameter 1.5, 1.498. This is what we have assigned in the no, 3D model. If you haven't done so over there and have used only 1.5 as the dimension, select this dimension, change it from a none in tolerance and precision to limit, and assign the deviation of minus 0.002 to have a lower limit of 1.498 and upper limit of 1.5. The next dimension for the cylinder is 2.76, and the third one what we have here for the flange is 5.5. There are 4 bolt holes that are running through in the flange, and this can be described by dimension 0.5. So let's also move this to the view where we see these 4 holes. So you may select this dimension, keep the control key on the keyboard pressed, and move it to the front view. Okay, I'll hide this one from the right side, and this the style by which it has been described here is across the ends of the circle. So select the dimension, and under leaders change the display with the diameter, so it is pointing as a single arrow as a leader line to the circular edge. And then we have got the dimension as 0.5, diameter 0.5. There are 4 such holes, so let's describe all of those 4 holes in the same dimension. Go to value under property manager, value tab, scroll down to go to the field with dimension text. We can add in here the text after 0.5 inches as 4 holes, and in the next line with the enter key on the keyboard, move to the next line and add a text there equally spaced on a diameter 4.24. So try to move the dimension to the right side to have no intersection with the section line. And the meaning here is when we say equally spaced on a diameter 4.24, we have got this pitch circle, or we can say it as a bolt circle, on which the centers of these 4 holes are located. They are at an angle of 90 degrees from each other. So this is what is being described when it's mentioned as equally spaced over 360 degree, which turns out to be like 360 over 4, giving you 90 degree. The next step would be to change the font style of the section line itself. This is by default, so we can change this. And also we will change the thickness of the visible lines, hatch lines, and the hidden lines what we have here. To assign the line thickness, open up the options under standard toolbar, and in it you have the tab for document properties. We go over line font, assign the visible edge to have this is the style, which is solid, and its thickness as 0.024 inches. So we don't have a default standard number here, so select custom size, and the standard value that is for a visible edge as 0.024 inches. We have got the hidden edge to be assigned as 0.012, and we'll change the area hatch fill lines as 0.0098. This is something we'll take it from the drop down menu. Say OK, and you should see a clear difference between the visible edges, the section lines, and the hidden lines. We can also change the style for the section plane edge that is being seen here. So it could be done using a layer toolbar. So you may turn on the layer toolbar by going over view menu, toolbars, and then turning on the layer toolbar. So when it's already turned on, if you see a tick mark next to it, so if you have to turn it on, simply go to layer and select that, such that the toolbar would be made available to you. So this is at the anchored at the bottom of the screen, or it might be floating on the screen. So once you see this toolbar, select the layer properties. So currently it has only one layer format, so click on layer properties to add a new layer. Click on new, and let me put this as section line. And in the style, we'll change the style to a chain, and thickness we can leave it as thin. This is 0.0071 in this case, or yeah, let me take it this way, and select the line, say OK, and they should get listed here in the available layers. So for now it is none. We pick up the section line and assign it the layer for section plane edge. Say OK. Try to arrange the numbers or the dimensions here as per the standard. So there's an intersection of the center line and the dimension. Try to keep them away without any intersection. We can even shorten the length of the center line. And do not stack them in a single row. So keep these dimensions slightly at a offset from each other. So this is 5.5, and then we have got 2.76, 1.5. This is the limit dimension on the bore diameter. The holes that are in here we have defined in the front view. The tangent edges to be removed from here. So this was described to you earlier, so I didn't do it in the second one. I did do it, but looks like it has come up again. So remove it from both the views, front and right side views, by making a right click in the highlighted orange box, going over tangent edge removed. Okay. The dimensions in the top view, try to put them outside the view. This is almost inside, so we can have 0.75 here, and the next one describing the overall height or overall depth. In this case, since we are looking in the top view, we have it over here with a smaller number followed by a bigger number. So that gives the depth dimension. And the note for the fillets and rounds, we have it over here. We now add the details like the surface finish mark. So we have got surface finish for the surfaces inside the bore, inside the holes that are drilled in here for bolt holes, and the back face. So these are the surfaces which are to be made smooth. So we do that by going over annotation toolbar, selecting the surface finish texture symbol. In the property manager that opens up on the left hand side, select a texture symbol as a closed texture symbol, which is indicating a machining required. We have the details in here. For roughness average, we assign it as 32 micro inches, and for the material removal allowance, we have this as 3/16 of an inch, which turns out to be like 0.1875 value to be used. So with this selected, you may drag and drop it onto the edges representing the surfaces for the board hole. So as I bring in here, I see a line getting highlighted there as orange in color. So that's the line on which it has to be dropped. You can control the font size. We can increase or decrease the font size if it is too big on the drawing view. So we select the other one here. This needs to be pulled out a little onto the outside, and the last one at the back face. So this is the next one. So let's try to rearrange all of these and put them in an appropriate manner. We have the first one here. We'll try to reduce the font size by some amount. So go over here in the property manager, uncheck the box for use document font, select the font, and let's select it as points. It's currently 12. I'll make it as 10, and that is good enough to fit inside there. We can pull this out to the right or to the left and make sure there's no overlap of this with the other node that we have. So we can pull this one down. I'll also give the same font style to the other two dimensions, other two surface finish symbols that we have there. So we'll make it as 10. This is based on the size of the drawing that you have here. The drawing view is having a smaller view, so it would be better to have these uh, in proportion so that the drawing becomes easy to read. Over here we find the arrow pointing from a surface which is within the material. So let's try to turn it around by 180 and point it from the open side. So this can be done by changing the angle. It is currently at an angle of 90 You may uh, switch it to the other side by clicking on perpendicular. This is something that you can use, or you can put in the angle of 270 to move it from the other side. The font size will make this also to 10, and say okay. We only change the font style in the next one. We have already done this. Okay, so we have now finished adding the dimensions, surface finish symbols. We have also made the line styles as per the standard. We will now add one isometric view or a pictorial view to describe the whole part. This could be done by going over drawing view again, select the projected view and project it from the front, or you can simply say model view. Let's make it independent, like a model view. Select the same model as bearing, click on next in the property manager and change the orientation to isometric. It is by default isometric here, so I will simply drag and place it in the top right corner of the page. We have got some good sufficient space there. Keep it over there. You change the display style to shaded with edges, so you can see this with the fully shaded. Accept this, and the tangent edges here will replace that as tangent edges with font. So right click in the area enclosed by it with a highlighted hidden line and say tangent edge with font. Accept this. Okay, you may bring the views close to each other. Try not to keep them too far away from each other, and they should not be moving out of the borders that are being sketched here on the drawing sheet. So we can bring in the section view to a little bit to the left here, closer to the front view. We have got some dimensions here, 4.24. This is something which we got as imported dimension. So let me hide this, as we have included this over here in the front view. And in a similar way, if there are any other dimensions that you still see are appearing, try to hide them or delete them and try not to have them as superfluous dimensions. So if they are to be specified in one of the views, try not to have them duplicated in the other views. This is what we mean by superfluous, not to have superfluous dimensions. We will assign layers to the roughness symbols, dimensions. It has a tolerance dimension. So turn on the layer toolbar by going to view menu, toolbars, and then activate the layer toolbar. It is floating in on the screen over here under layer properties. Under the dialog box for layers, add new layer for dimensions, another one for surface roughness, third one for tolerances. We assign a different color to each of these. For example, the dimensions could take blue color, roughness as red, and tolerances as dark green. Say OK. Let's assign all the regular dimensions under the So pick up all the dimensions, keeping the control key pressed on the keyboard, and then assign these regular dimensions under the layer for dimensions. I think I missed out the other two. Let me add them again. So these are the dimensions which do not have any specific tolerance. The one of the bore diameter 1.5, will put them under the layer for tolerance. The surface roughness symbols, pick them all by keeping the control key pressed on the keyboard and assign them under surface roughness. We can also put the note that we have here under dimension. So this completes the module number 10, and due acknowledgement to Mohammed Younas and John O'Brien, who has written this document for module number 10. There are a few tangent edges still appearing in here. Let me remove that. Okay, that completes this video on module number 10.